Good afternoon, everybody. Thank you for watching, whether you're watching live or you're watching the recording. I just appreciate you tuning in and getting involved in your education. So this week, it's probably a welcome and nice thing that we have a 2-week module that we're working on, right? So that means we have nothing due on this coming Thursday. Everything is due next Thursday. Right, pretty exciting, pretty cool. I'm sure you all are happy for that. And it is because we are kind of covering some big topics here, right? Like last week, unfortunately, we were unable to have our live class. But you did get the recording and you started working with new methods, right? Being able to write, if you're familiar with other programming languages, being able to write new functions. And these functions allow us to kind of take and compartmentalize our code. A term we've used in the past is modularize our code, so that we can take and we can reuse things over and over again without having to, rewrite everything. We said that the purpose of a function is to just take all of the things that do a specific action and put it into one contained block so that we can work with that. And so from here, right, now that we have this idea of methods under our belt, which we will review as we're kind of working through some demonstrations today, we're going to talk about conditionals, which is our big new topic for this week. And we're going to learn what we know about, we're going to take what we learn about conditionals and what we know about methods, and we're going to kind of put them together next week and talk about the concept of recursion and what exactly recursion is. And so really with conditionals, we've hit a pretty big point in our programming ability, right? Like I kind of teach this course because I know some people take it that, don't take any of the other courses. So I kind of teach this course kind of outside of the bounds of any of the other courses, right? I don't assume anybody already knows any of these logic structures or any of the other data structures that we'll be covering throughout the semester. So I really take it from the beginning and we kind of work through it. So even though like some of you have probably heard about and worked with recursion in some of my other classes, you've never done it in Java before, and some of you have never done it at all before. And so we'll save recursion for next week, right? The idea of a conditional on its own being pretty big, right? Because it kind of takes our program and it gives us the ability to make decisions. So let's start out like we normally do and just start out with some definitions here. The first term that we'd like to talk about here is just what exactly is a conditional, right? And, ideally sometimes we want our program to be able to make choices. Right, we want it to do one thing or another based on, something else that has happened. And that's where conditionals come in. Right, conditionals allow our program to do one thing or another thing, right, based on some other factor that's coming into play. Right, and we can look at a condition like a mathematical statement, right? There's a mathematician by the name of Boole, Boole, right? And if you've been reading ahead, you might have, or if you remember back to when we talked about Boolean variables, and if you've been kind of reading ahead, you might have seen us talk about a Boolean flag. These are items that are true or false. And mathematician, I believe his first name was George, if I'm recalling correctly off the top of my head. I could be completely missing that first name. But what Boole essentially stated is that all mathematic problems could be kind of boiled down to a series of trues and falses. And so when we look at conditionals, we're looking at basically whether or not something is true or false. And if something is true or false, then we do something else. And, when we're kind of getting into the nitty gritty of it, right? Like if those of you who took the Introduction to Programming Logic course, the CIS 115, if you remember back to when we were doing this sort of, programmer math, it's basically, some really rudimentary symbolic calculus that we were doing. And we were talking about propositions and, making sure something was true. And if something was true, then we'd do something else. And we looked at the concept of truth tables. And we looked at all these different things, right? And so all that stuff really comes into play when we were discussing the conditional. Because it's all of this sort of, bigger kind of logical math that gets us to the point of something being true or false. Right, so from here, in order to be able to tell if something is true or false, we need to be able to have something to relate veracity on, being able to relate true or false on. And that is our relational operator. Relational operators are used to check conditions like whether two values are equal or if one is greater than another or one is less than another. And it's the standard ones that you've probably seen a lot, right? There is something that is just a little bit different in Java, and that's when it comes to strings, which we'll have a look at that in just a bit. Right, but relational operators, they're used to check to see whether two values are equal or one's greater than or another. What we're doing when we're setting up one of these relational equations, we're asking ourselves, or we're asking our program really a question, and we're saying, is this in some relationship to another thing, right? Greater than, less than, equal to, greater than or equal to, less than or equal to. Right, and so these are our mathematical symbols that help us evaluate our conditions. And we determine our conditions to be true or false based on these relational operators. Right, and so here we have a list of those. X equals y, and that's X is equal to y. Right, and this brings me back to the idea of, separating the assignment operator, which is our single equals symbol, and our relational equals operator, which is double equals. Right, so it's one equals for assignment, and so we use that when we are assigning or reassigning a variable, so that we're saying this variable is equal to this other thing. And we use the double equals signs to check equality. And we're essentially asking our program the question, is this equal to this? We also have our exclamation symbol, which is our not operator, and we can use that in different ways. Not equal to, in this case, to say that X is not equal to Y. So if they're two different values, and that's where, that is one of those cases where conditionals get kind of fuzzy. Right, because we have to try to evaluate these statements like a computer. Because when we start looking at nots, right, it's easy for us to kind of think in the negative, in the inverse. Right, so if something is not equal to something else, then that's true if they're not equal. And we'll even talk about the Boolean flags, and we can actually have a Boolean flag that is inverted. So we can actually do a wrong key. We can actually do a not variable name And that's actually checking to see if a Boolean variable that we have triggered is set to false. And if this Boolean variable that we have configured is set to false, then the value that it returns is true. Which is where so that's where, when we're talking about thinking like a computer and thinking like a program would think, those are the places where we're starting to, see those things come into action. Right? Greater than, less than, greater than or equal to, less than or equal to. These are common symbols that we use a lot in just regular algebraic math, right? Like, I'm sure you all have seen these symbols many times over. But these are just checking a relationship. Is, in this case, x equal to y, or not equal to y, or greater than y, or less than y, or greater than or equal to y, and so on and so forth. Right? And so what we get out of here to contrast these from arithmetic operators is that we're not getting the results of a math equation, but we're getting the Boolean true or false as the response to see if our condition will run. So Java does have double equals. It does not have triple equals, to my knowledge. Since Java is already strictly typed, it doesn't really need triple equals, because the triple equals in JavaScript is for basically for strict typing to ensure that it is both the same value and the same data type. So since Java is strict, since it's strictly typed, it really doesn't need a triple equals, but I'm going to just Google that really quickly just to make sure. Yeah, triple equals is just strictly or just weakly typed language. Is just for weakly typed languages. Yeah, so we don't worry about that in Java. Now, we did say strings are a little bit different, right? So we don't, in Python, we can use our double equals to check and compare strings. In Java, we can't, right? Because as we've kind of discussed before, in Java, we kind of work with strings that are, strings in Java are a little bit different, right? And especially the way that we work with them in general, they become objects. It's an object of multiple characters that we put into a variable and it's held there. So when we're working with strings in Java, we actually have to use the equals function. So if we want to check the condition of a string value, so if we want to check a string value in relation to another string value, we have to take string value A, or in this case, string value X, and check that dot equals, and in parentheses, string value Y, or whatever our secondary string value is. So in this case, we're checking to see if one string equals another string. Right? We can't use our standard mathematical relational operators in Java to make this comparison. So let's just do a little bit of coding here, right? Like you can kind of see the basic example of what we're working with here in our as our syntax here in this example. If some condition, that condition is in parentheses, and then we have our curly braces after that. So let us head over to a replit window, and now since we have the benefit of using multiple methods, I can actually create multiple methods for the different things that we're looking at, so we don't have to have as much kind of crammed into our main method here. So I'm just going to get rid of the hello world that's in our main method. We'll go back to that main method in a little bit because everything that we run has to be ran within the main method. Right, and so let's take this and let's just create a basic condition. And we will do that like so. So we're going to create a new public void, and we'll call this one basic condition. And I don't remember if I say it in the one that we worked with last week, but these don't. So our main function here is a static function, but our other void functions don't have to be static functions. We'll talk more about that in a little bit. So I want to create just a basic condition function here. Right, if I want to, I can create an operator or a parameter here where I can bring in some value. And since this is a void function, we will have to print out from this function any results that we want from this function in our console. Right, we're not returning a value in a void function. That's for a value function. That's for later. This is a void function, and we have to do our conditional work in it. So let's take our if statement with a couple of parentheses. So we're taking a value n, which is x. X is our parameter. And we'll say greater than 10. Right, so we're just checking to see here. Simple condition to see if x is greater than 10. Fairly easy. Oh, I didn't call it x. I called it val. I thought about calling it x, and then I ended up calling it value. That's what happens at the end of the day. So what we'll do here is we'll just do a quick little printout. So system.out.println true. And the other thing that we have in a conditional system is, if we have an if statement, there's also else if and else, right? So what we want to be able to do here is, just to start off, we're just starting off with the basic. So let's just start off running this with just the standard output, just so we can kind of see what's going on here. So we're in our main function here, we'll call our function basic condition, and we'll give it some kind of value. So the first one, I'll put 12 in there, right? As we kind of did last week. I can show you basic condition, and I can put 4 in there, and basic condition, I can put 30 in there, right? So that value is being passed as the parameter into the method, and then whether or not that value is greater than 10, it will look inside of this conditional statement, and it will see true or false, and it'll run it accordingly, right? So if we run this now, we see on the output we get 2 trues, right? And those 2 trues are for my first call of the function and my third call of the function, right? Both of those places wherein the input parameter that I have there, the value 12, is greater than 10. We do have the one instance in the middle where the value is 4, where it is less than 10. And in this case, right, since it's less than 10, it sees this here. This returns false. And so it does not execute this code. Right, so if I wanted to catch all other instances, right, so if I say, val is greater than 10, system.out.println true, that's going to return true for every number all the way from 11, right, because 10 is not greater than 10, 10 is equal to 10. So it's going to return true for every number all the way from 11 to infinity. Which means that from 10 all the way down to negative infinity is not covered here. And so I can write other conditions. I can write else if conditions that would be paired with this if condition. So it would check the if condition first, and if that if condition turned out true, it would check the next else if condition. Right, we'll talk more about that when we talk about chained and nested conditionals in just a bit, right? But for now, I just want to introduce the all other conditions line of code, which is our else statement, ELSE. And so when we say else here, we're basically saying everything else. And so we can system.out.println false in this case. Right, and so if we run this now, we shall see we have true, false, true. Right, and these are directly related to our function calls or our method calls that we have here inside of the main method. Because we see that 12 is greater than 10, so it gives me the results that are in the first block. 4 is less than 10. So it sees this first one where it's checking to see if the value is greater than 10. That's false, so it jumps to my else statement and prints false. And finally, basic condition is 30. So that's greater than 10, so it prints the first one. So let's comment out these function calls here, these method calls. And let's incorporate a few different things that we've learned about so far to extend this a little bit by doing just a word check. Right, so I'd like to be able to take a word from a user and check to see if this word is what they have, what I'm expecting. Right, so I'm going to take it from a user, so I'm going to bring it in as a scanner. So that we're going to import java.util.scanner. Which also means that I need to create my scanner object. Scanner in equals new scanner on system.in. And I'm actually going to create, or I'm going to get the value from my user inside of the main function, or the main method, and then transfer that via a parameter to the secondary method, to the method where we're going to put our condition. You'll remember kind of when, in other classes and things where I've talked about parameters in the past, I kind of refer to it as like the pneumatic tube that goes into the bank. It gives us the ability to take data and other things from outside of our function and bring it into our function, which is especially useful in Java because everything inside our function is scoped to our function. We don't really see the use of global variables are a little more challenging to use in Java than in some things like JavaScript or Python. Right, so we'll take a value, which is going to be our string value of, let's just call it X, just because I'm not really feeling creative right now. And this is going to be a new string of in.next line. Like so. So what we can do right now is we can just kind of work with some incremental testing just to make sure that what we've done here works. Right? Because another thing that we also probably want to do is, as I'm kind of getting ahead of myself, just like enter a little prompt for our user. So system.out.print, we'll just say enter a word. Now remember that we use print instead of print line here because then it'll put it on the same line as our little input cursor. So we'll create a new function here. And in this new function, I'm going to make it non-static this time so I can just show you all that as well. So this will be public void check string. And we're bringing in a string value that we can call word, right? Because remember, it doesn't matter what we call our parameter here. When we bring it in here, it's a completely separate thing. So we learned that we need to use our equals to determine if a string is equivalent. So let's create a variable here. We'll create a string variable. We'll call it secret, kind of like it's a secret word, and we'll set it equal to a new string that we will write hello exclamation point. So now we can set up our function. And again, I am getting a little ahead of myself because I wanted to incrementally test this, right? Because one, I know a function call is not going to work here because I actually need something else, since this isn't a static function. So let's just go ahead and we'll just write a system.out.print line word, just so we can see this work really quickly. Which means I'm going to go back up here to my main function and create a check string call with the value x as my parameter. Now it's giving me a little squiggle line here, because I told you all it wasn't going to be as simple since we didn't make this a static function. To just call the function. Right, because one of the things that we can kind of think about when we are working with static is that when something is static, it belongs basically to the main class. It belongs to we say it belongs to the type itself, right? This is using static in Java is mainly it's sort of a memory management sort of thing, right? Like the static keyword is basically just used to say that this function is a part of this class. So in general, right, there's no real reason that we would want to say something is not a static function, especially if we were making it, if we were just doing something to where everything was a part of the same class. And so by default, when we have a static function, it loads it into memory with the base main class. Which means that if we want to have a non-static function, we need to be able to do this in such a way that we're actually calling a memory space for this object, because it's no longer a part of the base class, right? We have to kind of let it know what kind of object we want it to be a part of. So I can actually create an object here in main. And then we can attach that object to this function call. So I could use my class name in this case, which is main in this case. Create some variable name here, right? Like let's say obj equals new main. And so what that does is it creates a new object, which is a new instance in memory. And this new instance in memory I can attach to this non-static function, so I can give it some memory to live in. Because otherwise it doesn't have it because it's non-static, right? If it was static, it would just share the same memory with the base class. Since it's non-static, I have to give it some memory somewhere to work with. So now that I tell it to, make a new instance of this main object and attach that object to this function, it'll run. So what we should expect here is we get enter a word, and we should get that word echoed back out to us, right? Based on our other function that's here. So let's enter hello, and we get hello back, right? Which is exactly what we should expect. So now if we start to write our condition, we can check to see if the input word is equal to hello, right? Like maybe it's like a secret greeting to get into the application or whatever we're looking at. Right, so we write our if statement, if word dot equals secret. And so in this case, the dot equals is going to give us the equivalency check for this problem. And in turn, it's going to check to see if it's true. If it's true, it'll run this if code. So we can system.out.print line, something like you're allowed in. And then in our else condition here, we can say blocked. Right, so now we have our input condition and our if condition and our accompanying else condition. So if they get the secret right, they are allowed in. If they get the secret wrong, then they are blocked. Right, so we can run this now. We can enter a word. If we enter a word that's not our secret word, which is just hello, like let's say we entered apple, we get a blocked. If we enter a word like, say, hello, we get allowed in. Right? And we can see here if we just make a little tweak to this, and just instead of our dot equals, we add our double equals. We can just try it again just to see. I get blocked. Right? So why is that working? Or not working? Right? Because in this case, essentially what we're doing is we're doing some weird math, so they're never actually going to equal one another. Right? Because it's going by kind of where their location is. So since we have two different objects here in the print stream, it's always going to never be equal, basically. So which is why we want to use our dot equals function and check that out. And so if we say hello, we're allowed in. And also in this case, since we're not doing any, sort of data validation here, right, which might be something that we would want to consider, changing this all to uppercase or to lowercase or something like that, as we're kind of working through it. Then if your user forgets and enters in a lowercase h in hello, when you're looking for an uppercase h in hello, then they're going to get it incorrect. And they're not going to be allowed in. So we'd want to do some data validation in order to get that fixed. All right. Sorry about that there. Just had to make a quick response to someone on Teams. So in addition to our standard checks for equivalency, we can also add some different logical operators into our conditional statement. Oops, forgot to turn that off. These are our logical and, our logical or, and the one that we've already discussed here, which is the not. Right? And so if we are looking at the and or, if we're looking at the and or, if we have our logical and, which is two ampersands, it basically means that both part of the condition have to be true in order for the condition to be true. And the or can be one or the other. And so I was actually looking at something pretty interesting recently, and in the Python class, in the CIS 115, we look at leap year, right? And determining a leap year mathematically. And so we can actually use these ands and ors, these logical ands and logical ors, and the nots to see if we can kind of find a leap year in a much smaller program. Right, because if you kind of remember back, right, we can look at the fact that we are determining a leap year. So leap years are any year that could be divided exactly by 4. So if we use our modulo operator and we say year modulo 4 equals 0, that's one condition. But if it can be divided by 100, then it isn't, right? So if we look at, like, say, for example, the year 1400, right? That's not a good example. But say the year 1200, because that's a correct example. 1200 can be divided by 4, but it can also be divided by 100. And if we were to look it up, the year 1200 is not a leap year. Actually, it is. That's a bad example. It's a bad example because it's also divisible by 400. That's what I get for trying to pull an example off the top of my head. Because if it's divisible by 4, not divisible by 100, and divisible by 400, then it is. Like, what's the best? I think I have on the other screen my my better spelled out leap year program. Oh, no, wait, I got it here. Let's do it here. And that's the wrong one here. It's this one. I want to use this one. Slideshow from current slide. That's what I get when I have like 100 different slide decks open trying to explain things. If it's evenly divisible by 4, we check to see if it's evenly divisible by 100. If it's evenly divisible by 100, we check to see if it's evenly divisible by 400. And so if it's all of those things, it is a leap year. If it's not all of those things, then it is not a leap year. And so, in the Python class, since we're just kind of learning programming logic and we want to see how things are kind of working together, we do this as chained and nested conditionals. But in this class, since we're not really worrying about those sorts of things, we will be worrying about chained and nested conditionals, but we can look at it through a different lens and look at it with these ands and ors and nots, right? So let's make ourselves a new function. We'll make a public static void leap year. And we'll bring in some integer value for year. So in this case, all we really need is one if statement, right, to see if it's correct. We can say if year modulo 4 equals 0, ampersand, year modulo 100 equals 0, ampersand, year modulo 400 equals 0. Then we can print it's a leap year. Right, so in this case, it's just going to read my statement from left to right, and it's going to check to see if all of these conditions are met. because we use this and here. So if any one of these conditions are not met, then this whole entire if statement is going to return false. And I just used a print statement here like I'm writing Python instead of a Java system.out.println. Right, so if we do some modifications here in our main, instead of entering a word, we're going to enter a year. And we put this string x into an integer. And we just made it in.nextInt. Get rid. Comment this out. Comment this out. And then call our new function leap year with the value x in it as the parameter. We can also put something here like else system.out.println. It's not a leap year. All right, so now if we enter in something like this year, which we know this year is not a leap year because tomorrow is the last day of the month, so 2023, we get that it's not a leap year. I think the last leap year we encountered was 2020, which is going to throw us a wrench in what we have here, right? Because that was a leap year. But the way that we have this structured here to check all three of these would mean that it has to meet all three. So if 2020 was a leap year, it'll still tell us that that's not a leap year, even though it was. Right, I believe 2020 was a leap year. And so in this case, we want to try to take this and make it a little smarter. Right? And we can still make this a little bit smarter, right? Like this gets us our big years, but we can make it a little smarter. And we can add some ors in here. And if we add some ors in here and we group things together, then all of a sudden we're going a little wild with the way that we can structure these. Right? So we're saying if year modulo 4 equals 0 and year modulo 100 not equal to 0, then we can wrap that in parentheses of its own here. So now it's going to evaluate that entire piece as one statement. And we can add two of our bar characters, which is shift and then the key that's above the enter key. To create our OR. We'll grab this same code from earlier, paste it in there, and change it back to be an equals. And we can wrap this all in parentheses as well to get it treated like a singular entity or a singular evaluated statement. So now what we're saying here is if this evaluated statement is true, which are these two conditions here separate, that are and, so it's looking for an and for both of them, or this set of statements is true, which is all three of those other things that have to be true, then we can say it's a leap year. So if we run this now, we can run our 2023 again. We can get that 2023 is not a leap year. We can run our standard leap years, something like the year 2000. And we can see that the year 2000 is a leap year. Or we can run a year like the one that broke our logic in the last one, something like 2020, and see that, yes, it is in fact a leap year. So if you remember back to the big long one that we did in CIS 115, Introduction to Programming and Logic, we did a lot of nested conditionals here, but in this instance, we've only used one set of conditionals, one if and else statement. And this if and else statement in totality has the logic using our logical operators to actually find a leap year in just one set of if and else statements. And so that's pretty much, I think, all I want to do today, right? We're about 52 minutes, 51 minutes or so into our hour. So I think, and we've covered a lot of stuff. And we got another week to talk about stuff. So I think I want to stop here for today. Lots of big stuff that we covered here today. Next week, we'll talk about chained and nested conditionals. But more importantly, what we're going to spend more of our time with is the concept of recursion and making recursion work. So with that being said, we're kind of winding down now. So if anybody who's here with me live has any questions for me, please go ahead and throw them into chat now. If you're watching the recording later on and you have some questions, send them to me on Teams or send them to me in email. Whichever one makes the most, whichever one's easier for you, I can get it either way. Yep. And that's one of the goals, right? Is that it is similar to the other programming languages that you've learned. So if you've learned other languages, this shouldn't be too different, right? The big thing here is that it's basically, that's one of the things that I want you all to kind of get out of taking the different languages. When we work through Python, when we work through JavaScript, when we work through Java, or when you're doing any other languages that you might do on your own, you start to see these same sorts of structures over and over again, and you get them figured out. So they're basically the same. They're just in a different dialect, if you will, right? The syntax is different. So that's where we'll stop for today. We'll hang out with the music on for just a couple minutes, just in case anybody thinks of a last-minute question. Thank you all for watching, and we'll see you next time.